Good evening, everyone. Sorry about that. My name is Yemi Ayola once again, and I'll be your manual testing tutor for tonight. So, mainly, this is day one of manual testing. It's an interesting part. So, I welcome you all to this class today, and a couple of things before we start the class. It's just mainly two things I just need from you. Is one, just give me some time listening here. And the second thing is that if you've got a pen and paper with you, just do some jotting, write down. And of course, I know the videos will be available shortly after the class, but it's always good to just scribble something down, any important thing that you learned today. Having said that, today's class is a vital class, which means that everything I'm going to say today is something that is part of the process you're going to use as long as you're a manual tester, as long as you're an automation tester, anything that's got to do with definition of testing, even if you go to any field, this will be relevant for you. So that's me for tonight. So listening ears, just pay attention. Attention to details. That's just the only thing I need. So, what are the topics for tonight? So it's just the first one will be I'll be discussing about the background. So what my intentions are and how I'm going to take the classes. I'll take you to outside the world, make you feel the impact of what really testing is. Then I will bring it back into into the IT world so that you can have a better understanding when I start lecturing. Then the next thing is the different roles in software testing, and I'll be talking about the objectives, which entails different what types of testing, how testing are done, and that and the likes. Of course, the major ones. General testing principle, I'll be talking about that. Fundamental testing principle, testing process, I'll talk about it. So, and I'll give you time for Q&A, and you'll have people on ground to start answering your question. Also, as I'm lecturing now, if you've got any question at any time, just always pop it in the chat. I will go back to the chat. I will look at some of the questions. I will answer them. And obviously, I have colleagues that are on ground also. There are mentors there, there are bodies there, so they will be answering the questions as you're doing, as the lecture is going on. So it's very good. Once you have any question, just put it there. At the end of the class, you will all free to also have to talk and ask your questions and anything you need clarification about. So now that takes me to the first one, background. So I'm sure you all have been hearing the word testing. Some of you are not even IT based. You are from different background, from various backgrounds just to join the IT industry. So I'll just let me take you. Let's take it out of this place and go to normal world. So you'll be hearing testing, testing, testing. I'm sure testing as a word is not new to anyone. We all understand what the meaning of testing is. But we need a deeper understanding, a more clarity on what testing is. And that is the essence of this course that you're doing. So let me give you an example. Some example will be let's take it from a normal layman to say, if you want to make a cup of tea, hot tea, because the weather now is very cold. So you need a cup of tea. Of course, I put my tea bag in the cup, I've boiled water and I've poured it in the cup. My question to you is that if you want to take that cup of tea, you won't just carry that hot tea and pour it in your mouth directly. No, you won't. The first thing you do is that you will check, is it hot? If it's too hot, then you want to bring it to the normal temperature. Okay, let me wait. Or you start sipping it little by little, blow it. various ways to just make that tea cool so that it won't burn your tongue, it won't burn your throat. When you are trying to sip, check it, that is this hot? That time, exact thing that you're doing, those period, is that you are testing to know how hot that tea is, how the temperature you want that tea to be. That is what form of testing you are doing when you are taking a cup of tea. Take it again to you are cooking. Let's take for example you are cooking. You want to add your ingredient to taste. When you put maybe you put the first scoop of your broth inside your stew. And the next thing you want to do is that you want to taste it to be sure of what level exactly, how it tastes and how it feels. You take a spoon, just put it maybe on your palm, and you take the spoon, blow it and say, "Oh, do I still need more ingredients?" Yes, you add it into it again. You turn it, you taste it. What you're doing at the time is that you're testing that food, that stew, that pot of rice to see, is the salt enough? Is the ingredient enough? Is it to taste? Is that the amount that I really love? Is that the way I love my food to be? Even if you want to add spicy to make it very spicy, you want to know the level of spice you want to put into it. If you put too much pepper, it might be too spicy. If you put lower, it might. So you want that medium, that balance. So that's what you are doing at that time while you are tasting, looking for the right measure, the main balance there. You are actually testing. Take it again to writing. If I tell you, oh please, can you help me sign this document? It's just our normal self. You before you can sign a document, you want to scribble and be sure that that pen works well. When you check that pen by scribbling just little on a paper, what you are doing at that time is that you are testing. So if you can see the example I've given you for the cup of tea, when you're trying to blow it and make it that room temperature, what you're doing at that time is you're testing. When you're cooking and you're tasting the soup to be sure that you've got the right measure of ingredients in it, what you're doing at that time is that you are testing it. Now, I take it again that a pen is what you're trying to use now. You scribble on a piece of paper. What you're doing at that time is you're actually testing. Let's take a final example in this one before we go into the background. If you wake up in the morning, most of us, when we wake up, of course, you want to stretch your hand, stretch your leg, all you're doing at that time is you're just testing everything. Is he functioning as expected? Of course, before you get up from the bed. So all these are form of testing we do in our everyday life. Everything we do. So there's anything you're doing, there's a form of testing when it comes to whatever you're doing. So I'll bring it back now to our IT world. And the example I'm going to give here is just like you go to a showroom, you want to buy a car. Let's say you have a good car. In your mind, just think of the new car you want to get now. And you want to go to the showroom to get that car. By the time you get to the showroom, you have a lot of expectation. You want to test drive the car. You know what exactly you want in that car. You have read the features, everything online. But now this is something physical. This is the actual thing, the actual product. The actual car is right in front of you to drive, to test drive. So you want to get there. You want to see a lovely blue, shining car. Maybe it's got a 5 door, lovely alloy wheels. You want to see the wonderful things inside the car. It can park itself. It can drive. What? feature that you is actually that interests you concerning that car. That is the example I'm going to use here. So you want to get there. Your expectations are high on that car. You have read a lot about it, but you don't want to get to that showroom and find out that the car that you saw online, by the time you got there, you saw it a shining blue one, but by the time you got there, there are scratches all over the car. Instead of five doors, two of the doors are off. You won't dare to buy that car. You can't even. So you want to get there to see exactly what you want. And by the time you enter into the car, the first thing that you do when you want to enter into the car, you want to check whether that car is working. You switch on the engine. Oh, this is it. You move the brake. You drive the car all around. You feel the impact and know what that car is. That is just driving, checking all the features, using that car. What you're doing at that time is that's why they call it test driving. You're testing that car. Is that what I want? Do I actually like the way the hand is? Is the brake so firm? Those are the things that you are actually testing when it comes to that car. So, literally, everything I'm just bringing to is just how testing is done, how we do the testing. It's not different from what you know. But now we have ways, processes, procedures that we actually use when it comes to testing. And that, so you need to know when it now comes to you doing this testing, there are certain levels, procedures that you want to do when you are testing. So that's what we are going to be discussing here. So now that takes us to the next part, which is the different roles in software testing, in manual testing. So we have various roles. So what do I mean by roles is that as a manual tester, you can be a software tester. It's the same thing we do, but it's just different names. The way organization assign names to that role, but it's the same thing, the same process, the same procedure that we do. So you as a manual tester, you are also called a QA engineer, which is a quality assurance engineer. You can also be called a UAT tester. UAT meaning user acceptance tester. Is a test analyst. A test analyst. To be honest, we do manual. We say manual testing. Do no. With you can call yourself a manual tester. You can call yourself a test analyst, a UAT tester, a quality assurance engineer. You are still a tester. So it's the same process, the same thing we are doing. Web tester, QA test analyst, quality assurance test analyst. Functional tester, you're testing the functionality. What are the functionalities of those cars? You are testing the brake, you are testing the steering, the horn, all various things there. Next thing, you are also called a software test analyst. It's just named to it. Some will call you agile tester. So I can tell you predominantly several roles. It is several roles. Most of your roles won't be. I've been an agile tester, a QA tester, a web. So it depends. It's the same thing. So it's just the name of the role. So these are what you can be. Some are called automation tester. Automation tester is there. You're also called a penetration tester, security tester. So it depends on the role, but all we do is still the same process, the same procedure that we follow. If you don't know manual very well, is is a bit of balance even when you want to go to automation. So you have to be you once you know this trick, the foundation of manual testing, you will go quite a lot. Yeah. So what are the skills that we need as software tester? What are the skills? You have you the examples I've given you earlier regarding the cup of tea, regarding you tasting food, regarding you driving a car, all those examples. There's one particular thing every one of them were doing. They were doing all the scenarios I mentioned earlier. There's a particular thing they all were doing. And if someone can just type in the chat and let me know, before the person could take that cup of tea, he did something just to check. So, what do you think? They all just type it in the chat. Anyone, I just need they all. Even when he wanted to taste the food, there's something they were all doing. If you can remember, what do you think they were all doing? All the scenarios that I mentioned. When you try to taste the cup of tea, he was doing blowing it and ensuring looking at it before he could take that tea. Let me see. Someone typed in something here. Yes, they stirred it. That's a form. But when they stir that tea, before he drank the tea, what did he do? Fantastic. Deborah, they are testing. Fantastic. So everything every one of them were doing there was that they were testing. So the major skill we all need as a software tester, we must know how to test. Test. We must know how to test. So that's the main skill that we need. And if you can see this chart here, the main skill we need here, testing is the main skill. So every other thing that comes in, you learn, you get all this along when you are when once you know how to test software tester. So you will start getting in this internship. You'll be divided into various groups, which I believe you are in now. You'll be given a project to work on. You have your project mandate. So all these are the softwares you're going to work on. So once you're working on those websites, we already understand what testing is. So all this will come. It's just like testing is the big person there, is the big brand. Every other thing will be added to it. You learn it along. So software tester, you know how to test the system. You do the test planning, SQL automation. You know about the product. You use different Microsoft Windows to do that. And it could be a web application. It could be backend. All these are various skills that you acquire as you work along and you work in the internship and your project. So have it in mind, the major skill every one of us need is knowing how to test, just knowing how to test. And it's kind of is is very easy to do, but you just need to follow. If you are given a content, for example, a textbook to read, just let's say a page of a textbook to read, someone has written that text and he wants you to proofread. What you are doing at that time is that you are helping him to check the content and you're also testing. So it's something that is being created, is content. There is nothing new that you want to test that is not already in this world. So every application, is it mobile application you want to test? We have 1 million mobile phones, mobile applications all over the world. Just type it. You will get a lot good hints about it. Is a website you want to test? There are various websites that you will get a template. So it's just you understanding the process and procedure to do this. Now, you might be thinking that, oh no, with all this, is this job is it meant for me? I'm getting confused now. So before I start, I'm just starting the background just for us to familiarize ourselves. I want you to know, let's look at the salary expectation. This graph is still 2023, but I can tell you, if you work so hard, your 2 hours, 3 hours daily in Blue Sky, in this project that you're working on, really just 2 hours, 3 hours, consistently, I tell you, you'll get, I will show you the marks that I'm expecting, my expectation from you guys at the end of this course, even before the end of the course. Your very first month, second month, you should start putting out your CV. Don't waste time. You start putting out CV, start going after, because most of these things would have been taught. You are now hands-on on the project. So it's like a work field for you. What is our salary expectation? This is a graph. I took it from 2005. This time, of course, it was just still low. This is 2023. To be honest, I can tell you that the max is over this 100. But I took this as an average just for us to see. At the end of this course, you should be at the from 50. That's the minimum I always expect at the end, because you've got full hands on. You have various tools to play with, and they are the latest tools that they use at our fields now. You have the time, you've got mentors, you've got people that can help you attain what exactly you have come to do when it comes to manual testing and everything. So I'm expecting at the end of this class 50, 60 when you're negotiating. But of having said that, is the way you work. Like you see, there are juicy salary there. I can tell you, there are some that will say, no, this is not your money. People that know me, that yeah, I'll tell them in Blue Sky, your Blue Sky people, I'll tell them no, that's low for you. Tell them, go back and say this. So that's the way because we know what has been impacted. We know we know exactly what you know. So if you can set the salary expectation, so what are you waiting for? I'm waiting to see all of you in this field. I'm waiting to work with every one of you. So hopefully, this will lead us to where we start our main class for today. This is always a day one, as I've said. It's just to walk us through most of the things that we need to do. So I'm going to be talking about who is a good software tester. You have been hearing about manual testing. You've been hearing about software tester, a test analyst, a web tester, automation tester. What is the essence? What's the main thing that make you a good tester? One, good verbal and written communication is key. I always tell people, you don't need an epistle. What happened when I log into the website, copy the website link, put it, take a screenshot, including the error that you're getting, including the URL, the endpoint, that the HTTP. Take a screenshot of it. When you take the snapshot, put it there. When you click on the link, I get this error. That's it. The picture says it. Good written and verbal communication. Communicate. Just make sure you can write the step to reproduce it. It's just like you are not you get to a doctor, a patient gets to the doctor and wants to see the doctor. He's going to ask you what is wrong with you. So you must be able to communicate, oh, I'm having headache. That's it. So he immediately he understands, oh, he or she's having headache. Okay, take paracetamol. Then we know the exact thing to do. But if you get to the doctor and you say, I can't remember, there's no how we can help. Good written and verbal communication. One line. Let me understand what has happened. What message are you passing across? Do you have a picture? Most of the time, I encourage people to put a picture. And the reason I say pictures, the screenshot really tells a lot. You did not form that picture. You did not form that screenshot. Is where you got it from. So it's easier. You won't. No one will go back. The developer does not need to go back to you or ask you any question. What's the next thing? Passion. Now you and I, we are here. You're listening to me now. You have the passion. You have the will attitude. You really want to learn. That's why you're in this class. And to be honest with you, you've not made a mistake. You are in the right class. You must have the technical skill and the analytic skill. So the technical skills are coming after. That's where you have your the programming language, the automation part that you're going to work on. You must have the attitude. Then productivity. That's why I said two, 3 times, 2, 3 hours. Just try your best. Be consistent. I know the schedule is tight. Your schedule, it is, but try your best to dedicate your time. You've come in here to learn. Please ensure that you gain most of the time. Yeah. So, what are our objectives? There are things that we want to learn here. I've been saying the word testing, testing. Tell us, tell me exactly what this testing means. That takes us to these 5 objectives. What is testing? Why is testing necessary? What are the general principles of testing? Fundamental tests, testing. Then I'll give you self-assessment question. I'll ask you the question and I expect you to tell me. So you have to pay attention from now that I'm saying. Because once I ask a question, if nobody answered, I'll start calling names. And if you get the question right, you get lollies and candies. So the first one, testing. Yeah, me, you've been talking about testing, testing today. What exactly? Bring it to IT word. Just tell me a, just a simple sentence what testing means. This is it. This is an activity that is performed to demonstrate that something is working as expected. Simple. When I asked you, pen, you wanted to write, you want to sign a document, what you are doing is that you're checking, is that pen working as expected? That's the reason you scribbled it there. You drove the car from the showroom, test driving. What are you doing? You are checking if that car is working as expected. You are boiling you are cooking your soup, you're adding the ingredient and you're tasting it. What you're doing at that time is that you are checking if it's working as expected, if this food is exactly what I want. That is the simple definition of testing. This is an activity that is performed to demonstrate that something is working as expected. Now, most of you might be thinking, is testing for me really? Are you sure? I know the question is running through your mind now to say, really, is this for me? Okay, let's find out. Let's find out. Who can test? Who can test? When you were putting that when you were making the cup of tea, anybody can taste a cup of tea. When you were cooking the stew, I can call someone, please, can you help me check? Is the ingredient, the spice, is it very lovely? Does it taste good? That's you called someone aside yourself. So anybody. So if you're looking, how can I taste? Oh, I love this picture because it reminds me of chemistry, physics, and anybody can test. Anybody can test. Testing is not rocket science. It is not. Anybody can test. And I'll tell you, it's an interesting part. Once you understand the process, the procedure of testing, manual testing is very easy. It's a very easy way to test. Anybody, you can draft anybody. Just tell them this is how the application works. Go in. You don't even need to tell me about an application. Just give me 5-10 minutes walkthrough. I'll break that system for you. That's the way every one of us are. So anybody can test. What can be tested? What are the things that we can test? I've taken it outside, I've brought it inside, that's used normal um, things, items to describe testing. I brought it back into IT. Now, what can be tested? Two things can be tested: hardware and software. Hardware. Hardware. What are hardware? Physical device, something you can touch and see. An example, I'm sure some of you are listening to me on your laptop. That's an hardware. Then the software cannot be touched or seen. E.g., that internet that you are using to connect now to listen to me, you can't see it. You just know something will come up. Your gains, there are things behind it. So two things, hardware, software, is what can be tested. Testing is just the activity to show that something is working as expected. So let's go to the how. How? How can the software be tested? How? You've been saying it. So tell me now, how can this be tested? How can the software be tested? So two ways. And one of them, we are doing it now. It can be tested in two ways. First one is manual testing. That's the class we are in. Why do we call it manual testing? You are still going to find out furthermore about it. So it's because we are not going to use any tools. We are not using any tools. Nothing is going to be done without any tool. So you don't need any tool to do manual testing. Though you can import it, we've got some tools, but you can write it on a spreadsheet. It depends. If it's a traditional way, you write it on a spreadsheet. Then the second part is the automation. So automated testing. You execute your test cases with a tool. We have various tools that we use. So here you get your Visual Studio. You're going to add various libraries to be able to work it. There will be a step-by-step scenario. It's the same manual test cases that you write, just a format of it. You want to automate it. So it's two ways. Don't forget, previously I said what can be tested? Two things, hardware, software. How? How can it be tested? Manually, automated. Then that takes us again to software testing. What is it again? And it's just for you to know that software testing is the same thing as testing. It's the same thing as manual testing. It's a discipline. It's a name of a role. This is an activity that is executed to demonstrate that a software, what are the software? Mobile application, web application, um, packages, you can say programs, you can say systems, you can product items. Those are various softwares. If it's working as expected. So that is what software testing means. It is not complex at all. It is not complex. It is not difficult to implement, execute, and practice. It is a discipline. Software testing is a discipline, just a name of a role. So, software testing is just like testing. I told you, I said all those roles that I've listed, all the things that you see that I'm talking about, it boils down to one thing is testing that things are working as expected. It's not complex, it's not difficult to implement, execute, and practice. Software testing is a discipline. So, now, why do we test? You would have been wondering that, okay, what's the essence of testing? Why? Let's go back to our previous scenarios that we've spoken about. Talk about the cup of tea. If you don't check that that cup of tea is hot and you pour it and you just drink it like that, what do you think will happen to you? You'll have your tongue burn, you'll have your throat that will take you to the hospital. It might be a major surgery. So it's risk to life. So now let's talk about the food that you were trying to taste. If it's too spicy, you might not be able to eat it. Waste of money, waste of time, waste of resources. Let's go back to the car. If it's not tested properly, that could lead to death. So, various things that we consider when it comes to the reason why we test. It is compulsory that proper testing, the right testing is done on a software, an application, a product, a package to ensure that we have it error free. We're still going to talk about that. To avoid software failure, a system needs to be adequately tested and the right sort of testing needs to be done. What are the consequences if you don't test? I've said some of this. Loss of money, loss of time, loss of business reputation, injury, and death. So, all this, we don't want it to happen. That is the reason why we test very well. Even look at it from medical perspective. If any drug or any um any we want to maybe a drug or an injection, they want to use it on people, they don't start it immediately. They test it on various animals, things, just to be sure that things are what is working as expected before they use it on human beings. They need to verify, they need to validate it. How long? What will happen in the next 10 years to this pet that we've used this drug on? It doesn't work for the animal or whatever test the test agent is, then it's difficult for you to use it on other people because definitely it will lead to death. That you will compensate the family. It will be another form for people to a lot of things will happen. So hence, people you things proper testing needs to be done before items, drugs, products are used. Business reputation. If for instance you want to get an item and it's not tested properly and you use it, you won't want to go back to that organization again, or to where you bought the item. You would even tell others, don't go there because they don't have good products. So all these are the things that are being considered, and they are the consequences of why we need to test. And there are various level of acceptable risk when it comes to testing. So what I mean is, the way you are going to test an e-commerce application is different from the way that you're going to test maybe a financial application. An example, let's say for example, you have an application that you have to pay, you have your interview, and maybe at the end of payment, you have there are some ways that you can check on the laptop, maybe like using the developers tool. Some of it you'll be able to see some details in terms of password, PIN, and everything. Hackers can go into people's shopping or accounts and look at their details and go there, wipe out their money. So those things are what you actually want to avoid. So the way you are going to test the application will be so thorough than the way you are going to test a maybe just an e-commerce application to say just go there, navigate, come here and see, no payment involved. So those things are kind of different. And the way you're going to test maybe a vehicle, for example, the one we went to the showroom to actually check. And in the showroom, you were able to test drive and you take it out. The way you're going to test it is different from the way you're going to test a normal small bicycle. So those are the way is the different testing is that with the car, you know that if you don't test the brakes properly, there's every possibility that if it goes out there and the brake is not proper, then what does it? It leads to death or injury. And what we are afraid of here is loss of life. So all these things are factors and the way we are going to test, and we are going to come to that in this class also. So that takes us to these three brothers. I call them three brothers because from one leads to the other and the other leads to the last one. So who is the first? We are going to talk about the first brother, and the person is Error. So error, an error or mistake leads to defect, which can be which can cause an observed failure. So an error, or you can call it mistake, it leads to a defect which can cause an observed failure. So that is an error. These three brothers work together, and as I'm going on, I'll talk about it. So error. The error is human mistake. An error appears not only due to the logical mistake in the code made by the developer. Anyone within the team can make a mistake during this phase of software development. So error is not just is human mistake, but it can be made by anybody. It could be maybe during the coding phase, which is unit testing by the developers. It could be the business analyst, maybe the requirements were ambiguous. They didn't. It wasn't. It was maybe not enough information. It could be also the client, the customers. They weren't able to provide us with the necessary information needed for the application. So maybe part of it was guessing, and all that could lead to error. So with these levels that I'm talking about now, could be any one of us. And it could be testing team. Maybe we don't have capable hands. We don't understand how the application is working. Some might be tired, sick. So all these factors as boils down to the team at large. So before I move further to examples of these, is that have it in mind that you as testers in the intern, you'll be working in an agile environment. Agile environment. Shut that down. Agile environment. So what it means is agile spelled as Agile, agility. So we've got various groups, various people in agile environment. So it comprises of a project manager. It depends on the project you're working on. Project manager, that's PM for short. Scrum master is an agile environment. So a scrum master is needed. So scrum master and SM, that's what it means. A business analyst, that's a BA, which is key also in the project. We need a product owner, that's a PO. Some organization have a solution architect. You've got data analyst. You've got developers. Then we've got testers, which is you and I. We are part of the team. So all these are the people that form an agile team. So it could be anybody within it. So just have it. It could just be that the BA, and once the BA doesn't understand the requirement, honestly, to be telling you, that's a fall again. Because if he or she doesn't understand the requirement, it's kind of difficult for you to relate it to us. They are the ones that are client facing. They are the ones speaking to the product owner. They're the ones speaking to the client to get information. Then they relate the information to us. So if they don't understand the information, how do you and I want to know what they have discussed with the product owner? And that's why you always ask questions when you're doing your sprint planning, when you are coming together. Once your task is picked, you have picked a task and this is what you're meant to do. If you don't know what you are meant to do, if the story is not well explained, if it's not broken down, if the acceptance criteria you don't understand it, please call it out. Excuse me, the BA, I don't understand this. Can you break it down? What is expected? You have said that we should be able to log in. If I want to log in, what are my criteria? What are the valid things? Please, can you add acceptance criteria there? So all those questions you should be asking when it comes to you talking. So for instance, examples of error, if you see, it could be the business analyst, maybe misinterpret or misunderstood the requirement. It could be the customer insufficient or incorrect information. It could be the architect, maybe the data. It could be the people within the team. So maybe unclear or insufficient requirements. All these are examples of errors. So remember, error is human mistake. So that leads us to the next brother, which is defect. What is defect? Defect. Defect. Defect is inconsistency between expected and actual results. Now, if you've got a pen or a paper, write the word expected and actual results. Expected results, actual results. These two words in your testing career, do it automation. Even as a BA, as anything, believe you me, everyone knows the word expected result, actual result. And I'm going to explain it to you now. But this is interview question. Expected, actual, expected result, actual. What is expected? Now, I talked about BA previously, that he or she might not understand the requirement. They are the ones that have gone to product owner to ask to get all the information, and they're coming to relate it to us. Now, if the business analyst have given us a requirement, user story, and this is how it's going to be, what we take from that user story. Let's take an example. We'll say login is the user story. As a user, for me to be able to log in into Blue Sky, in order for me to log into Blue Sky, I need to have my login details or login mechanism. So, what are the things that are the login? So, the prerequisites, I must have registered, um, I must be a valid user, and must be able to log in, add the numbers of characters there. So, that is what we are expecting. That is what the BA is expecting. That is the result of what the BA is expecting. So once I write my test case, the expected is from what we have in our user story. That is what is expected. So the BA is expecting that for you to use the Blue Sky application, the Blue Sky Citadel application, you must be able to log in. You must have a user login. You must be a valid user. Those are the expectation. Now, when we have finished the development and you're not given the application and you're seeing the application now, so the BA in your expected is say you must be able to log in. So you'll be able to register with a valid details, and so anything you are doing at that time when you have the actual system is the actual result you're recording. So expected is before actual. Your expected is from what the business analyst have given you. From what you have in your user story is what you derive. That's the way you derive your expected result. Your actual result is when you have the application with you. Please, please, interview question. What is the difference between expected and actual result? All these little questions can get you a good job. Because if you understand it, the interviewer will feel safe that he or you know your stuff. So don't forget, defect is inconsistency between expected and actual. So why did I say inconsistency? Why is the word inconsistency? It's because if what is in expected is not what you're seeing in the actual, then is a defect. What you have in the expected, what is written in your user story, and now you have the application, is not the expected. Maybe the login page is meant to be color green. By the time it's meant to be color blue, by the time you got into the login page, it's color yellow or red. Inconsistency between expected and actual. So my expected was a green, it was a blue color. My actual now that I've seen is a yellow color. This the way I can explain it very well. Everything, so any test you're writing will have an expected and it will have an actual result. We'll talk about it further. Remember, twin brother, expected and actual result. So a defect is a software product. A defect in a software product reflects the inability of the software to comply with the specified requirements subsequently. So what he's saying is you must, if you cannot comply, if there is an inconsistency, if there is a difference, if there is an inability for you for that product not to comply with what is expected, then it's a defect. So a defect in a software product reflects the inability of the software to comply with the specified requirement, subsequently prevent the software application from performing the expected work. So if it does not, if it's meant to be green and it is meant to be blue and is yellow, then it's not working as expected because that's not what we are given. So listen now, an error that the tester finds is known as a defect. So you can see now, the first brother has come to join the second brother now, defect. You will see where the two of them are still going to lead. So now we've come from error, we are going to join. So it says an error that the tester finds is known as defect. The defect is also known as fault. So some call it fault. Most of the time, we call it either defect or a bug. So you can call it fault, you can call it defect, you can call it a bug. But most of the time, it's defect and bugs. So that leads us to failure. Failure. Failure is a consequences of a defect. So you can see now, the three of them have ended up to be one. So when you find an error, definitely it will lead to a defect. A defect will lead to a failure. So once you find an error, it will lead to a defect. The defect will lead to a failure. If something is not working as expected, the end product of it is that it has failed. Then it's a problem because it's a defect, it's an error. So all these three brothers work hand in hand. It is the observable incorrect behavior of the system. Failure occurs when the software fails to perform in the real environment. So you'll be given an environment to test on. So what it means is that it's the same environment. You are going to have a test environment. There's something that you will understand it when it comes. So there is a test environment where we testers and also members of the project team are privy to. So we are the only ones that have the access to that. No public can see it, nobody can see it. I cannot see it if the link is not shared with me, if I'm not part of the project. So if you are the only one, you'll be able to see it. When we want to make it public, you would have tested it. Everyone is happy. It's gone through UAT, other eyes. Everyone have tested pre-prod, production. Then we'll make it live. Then the public will see it. It's the same screen, but it's just that we change it in the various environment, the same look and feel of it. But each of those environments have different configuration on how it goes. So the real environment, if it fails to work there, then it's a failure. In other words, after the creation and execution of software code, if the system does not perform as expected due to the occurrence of any defect, then it is termed as a failure. If it's not working as expected, it's a failure. Not all defects results in failure. You'll know about that. Some might be in the code and we may never notice it. So that takes us to the 3. Error, defect, failure. So before I go further, which is keeping software under control, quick question. So everybody on the chat. So once I'm saying it, I'll let you know. What can be tested? What can be tested? I'm waiting. Just type it in the chat. Type it in the chat, please. What can be tested? I've told you I'll be giving you self-assessment as we go. I can't hear anything. Hello?
Kaya, good evening.
Can you hear me?
Yes, I can hear you.
Someone said he cannot hear me. I can't
Yeah, I
hear
can hear
you.
you, man. I can hear you, man. I can hear you, man.
Okay.
It's me.
Please, can you? Yes, thank you so much, Victor, for confirming. Please, can you unmute now? So who can't hear me? That I think. Okay, let me see the person that wrote that. Okay. No. Okay. So I said, what can be tested? No. Someone said anything can be tested. I mentioned 2 things. I mentioned some things that can be tested. So remember, and as I said, you must jot. Bugs are possible defects. Okay. So yes. Yes, Ogunyemi, is it essay? Fantastic. Hardware and software. Rebecca, fantastic hardware and software. Deborah, yes, hardware, software, fantastic. Okay, I'm seeing it now. I think those were just previous questions. Fantastic, yes. Okay, yes, I can see it. So those are the things that can be tested. How can they be tested? How can software and hardware, how can they be tested? I want to know if you're following me. Everyone that I've called their names, don't worry, I'll send your lollies. Fantastic manually. This very good, very, very good. Manual and automated, fantastic. Well done, Deborah. Well done, Ugochi. Fantastic. I can see everyone. Great. Yes. I can see you all. Yes, well done, Johnson. I can see Emmanuel. Well done. You all understand. So that gives me that you're all listening. So we are getting to another tricky part, which is keeping some software under control. As we go on, please, if you have any question, pop it in the chat. I'll still go back to the chat. Keeping software under control. So we have been talking since about this phase of it. So keeping software under control, you'll be wondering that, is it possible that we can test everything? If it's a little application, you might feel you can test it, but there's a tricky part. It's impossible. So let's go to it. Exhaustive testing of complex system is not possible. It is not possible. So let's take an example. You have a big application, an application that you're working on. You must have written your script and everything. You've gone through it. You feel that you can't say, let me take an example of the car that you went to a showroom to drive. If you're the one testing it, you can't say that if I start driving that car and speeding for 200, I'm on 200, my speed. You can't vouch and say that with that, I won't have an accident. Anything can happen. You might think you have tested it. Anything can happen. You might have various scenarios that you have walked through. But I can tell you with obvious sense that if you give another person that application that you have tested, that you're confident about, is going to find a bug there. I know that. If that second person finishes with that application and you give it to the third person, I can tell you again, he or she will find a bug there because we are all testing from different perspectives. What you can see at this moment is different from what I can see, is different from what she is going to pick up when you're coming. So now you have been looking, I've been looking at this page. We all have been keeping our eyes in, keep the software under control. You have been looking at this same page that I'm displaying now. After a while, you are used to this page. Maybe let me give you 2, 3, 4 days. You've seen this page, you've seen it. If I tell you to test it on the 50th day, you say, no, there's nothing wrong there. But if I give it to someone new on that 50th day to pick it, it will find a bug there because it's coming on a different level, new eye, new everything to check, to validate that screen. And you would, if you now see the error, you know, oh, but I tested this. So that's the way. So exhaustive testing of complex system is not possible. You can't beat your chest to say, I've finished it. This application is error-free. No one can hack the system. It's impossible. So is it possible to run every possible test, simple or complex system? That is where we have the word prioritization. I'm still going to talk about that. So exhaustive testing of complex system is not possible. If every test have been run, testing will go on for long time and product may never get into the market. Let's take a mobile phone. We have various versions of, let's use iPhone as an example. I think we are in 15 now. I know in the next 2, 3 years, we'll be getting up to 20. So now, if iPhone 15 came in this last year, late last year, let's take an example of iPhone 14. If you are a tester and they were given to test iPhone 14, and because you don't want any bug to be in the iPhone 14, so that they will say, yes, there's no bug, it's bug free. You tested it from January 2022 to January 2023. Yeah, I mean, have you finished testing? No, I've not finished testing. iPhone 14 is still not tested. We can't take it to the market. By December 2022, have you finished testing iPhone 13? I mean, iPhone 14? No. We still have some bug. We can't test it. Okay. They gave till 2023, July. Have you finished testing iPhone 14? No. I've not finished testing iPhone 14. iPhone 15 is going to come out. So iPhone 15 came out before iPhone 14. Is that possible? No. So even if you continue doing that test from now to tomorrow, then it means we have to wait for iPhone 14 to come out. Then when iPhone 14 come out, we start the whole rigor again to do iPhone 15. Don't forget iPhone 16 needs to come out. iPhone 17 it will come out, 18, 20. So it means because of one iPhone, one version, it will delay others. So we will not be able to bring those products out. So that's where it leads us to. Is it possible to run every possible test, simple or complex, on or complex system? So we need to prioritize. So how do we prioritize? You would have written your test cases. What are the risks in this iPhone? You will look at all the features. What are the new features that they've added? We want to test the new features because in iPhone 13, maybe the button, this is the new button that they've added. You need to test the new feature that they have added in iPhone 14. Don't forget, iPhone 13 have been tested. So we just need to do a regression testing on that iPhone 14 and on that iPhone 13. So that will come after we have tested the new features because we want to be sure that the new feature that we are selling to people is working as expected. So that's the first, also all the features that is going to come in for iPhone 14, all the new functionalities that is going to come in for iPhone iPhone 15. We want to be sure that it's tested before it's tested. Those are our priority. So you list that as your priority. If you have time, that's your risk point. Because if that is not tested properly, then there's no point. There's no point we bringing out that product because that is what we are selling. That is the new features is what is going to come out of the product. So if those new features are tested, you would have prioritized it to say, this is what we are testing. Then the next bits that is coming in are the ones you do for regression. What has been, because we know it's iPhone 14, we've tested it, it's already out, people are already using it. So it's little thing. So it's the features that are coming in. So that's the way you prioritize. With large and complex system, it will never be possible to test everything exhaustively. In fact, it is impossible to test even moderately complex system exhaustively. So that leads us to a point where you'll be asking, how will I now know that I have finished testing? So that's the next thing. When is testing enough? I have told you, I've just explained how to keep the software under control to make sure that you are within that time frame, that deadline of testing. You have run the priority. Let's take an example. Just pop it in the chat. If you are given a car to test, what are the things that you feel that is priority that you should quickly test? What will be in your I rank? Let me see what class will say. The first thing that you expect that you will test when it comes to fantastic, fantastic. Oh, yes, break, 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 great, break. See, great, the engine, those fantastic. Because the reason you said so is because you know that break without that is going to, let me see what others are putting again. Yes, the engine, the key starter, because if you cannot start here, the brake, the engine, these are lovely ideas. They are the key things you're going to test in this thing. Like operating system can be tested too. Yes. So all these are the things that we need to test when it comes to a car. Great thing. So that's your priority. If you have to test that brake, you can waste time on that brake. That is your risk point. You test the steering, you test the airbag, all those features. Fantastic. The engine. If there's no engine, the car will not move. If there is engine, there is brake, and there's no key start, the car will not move. So all these are interwoven. They are the priority. They are the key things. So now when you test them, when will you know that testing is enough? So that takes us to these three main points. Just take it as two words: testing and risk. Twin. These topics are still going to come at the final topic, day 6. That's going to be the last topic of it. As we go further, please, if you know you don't have the manual testing textbook, we have a soft copy that we'll provide, so that we use. If you can read it, it's just 6 topics inside it. So you can ask the admin for it. I'm sure they have that. They can post it online. You can read it. So testing and risk. Testing and risk. So whenever you are testing, be checking the risk. Look at those ideas that were given when they were testing the car. They were bringing out the key. So as you're testing, you are checking the risk. You set the brake. You talked about the engine, the key starter. You talked about the operating system. All these are the things that you're testing along. Likewise, as you're testing, you'll be testing and you'll be checking the quality. Is this good? Is this okay? That is the other part. Is this going to look good? Okay, we started the engine. Should we put the key start on top of the steering wheel, on top of the wheel, or on top? So all those things, you want to get the right quality out as you're also testing. Then when exactly do you know that enough is enough? And that's the reason that when you have prioritized, if you have tested the risk part, you have tested the brake, you've tested everything. If what is left at the end of the deadline is we looking at maybe the color of the car is meant to be blue and they paint it red, or there is some sharp, all these are cosmetics. It won't cause any harm. They're cosmetics. Or maybe we wanted the alloy wheel to be blue and mixture of silver and black, but it's currently yellow. Those are minor things. They are kind of different. So, but you have gone further. You have tested what is so. If they tell you, "Oh, we've got cosmetic bulk," it's a nice to have. It's just nice to have. We don't need it. So that's when you decide enough is enough. Remember, when you are testing, always have it at the back of your mind. I'm prioritizing. How do I prioritize? I'm testing. I'll look at the risk. Put the risk first. Next, put the quality. Next, you bring down every other thing, maybe the cosmetic part of it. Then you can now decide that, well, I've covered 95% of the risk part. You're confident about that. Then you are left with the cosmetics one. We can still do with it and be fixing it as a. So that's the way you make sure that you understand when testing is enough. If you are going to test the cosmetic part, wasting time on it, and they call for to say, can we have our product? And you've not tested the risk part. Let's take a financial application. Then that is loss of money. Because people can go in there, shop without paying. And you won't be able to trace it. So all these are key things that you need to have at the back of your mind when you're testing. So that takes us to the interesting parts of this. As long as it's interesting, please and please bear and put it at the back of your mind that they are great things that in your testing career, throughout your phase, these are necessary. General testing principle. We have 7 of them. 7 of them. Number 1, testing shows the presence of bug. Exhaustive testing is impossible. Testing shows the presence of bug. Can you agree with me? Yes, because we said if things are not working as expected, so it shows the presence of bug. Exhaustive testing is impossible. I've just talked about that when I said keeping software under control. So that's what exhaustive testing is. Early testing. What is early testing? That's why you're an agile team. So as you're having one item, one user story, we are testing it, they are building it, we are coming together. So immediately your team starts and you've been given a project mandate, testing starts immediately. Start reviewing the user story, start asking questions, start going back. Excuse me, I don't understand. Can you explain to me? You can go back, you and BA can have a chat. Because in Agile, is continuous delivery all the time. It's continuous integration. You come continuously, changes, we we adapt to it. We adopt it. Any change that you come in, that is what Agile is preaching. Bring it in, we'll do it. So we too will start testing early. Defect clustering. Where exactly do we have those defects? Where? So we want to know where is clustering. Where exactly is the risk? How can we find it? The pesticide paradox. Pesticide paradox. It doesn't mean that because you have tested, like what I told you, I've looked at the page. It doesn't mean because you have been performing certain type of test all the time, it means it's bug free. No. What pesticide paradox is talking about is that doing the same test on the same thing will not find new bugs. It won't find new bugs. So which means that if you keep looking at this screen, looking at this screen, looking at this screen, I will not find, I'm used to the screen. I won't find anything new. But give it to next person, he or she is going to find something new. Then the sixth one is testing is context dependent. So what it means is that you put an input, you get an output. For you to test, if you want for you to test that a pen is working, you need a pen and you need a book. So you need those two contexts. So that's what you're going to use to do it. You want to test that your soup is good. You need a soup, you need an ingredient. So you get an input. When you put an input, you get an output. So the same way that it works in testing. So you see, testing is context dependent. Then the final one is absence of error fallacy. It's a fallacy. When you say, oh, no, there's no error, it's a fallacy. All false. So remember, general testing principle. 7, testing shows the presence of bug. Exhaustive testing is impossible. Early testing, defect clustering, pesticide paradox. Testing is context dependent. Absence of error fallacy. This point is key. And that takes us to another big part of, and this is more of the last phase of today's class, fundamental test process. Fundamental test process. I tell people, I preach what I practice. So what I do is what I'm telling you. As of today, if I'm going to tell you this is what I'm working on, this is the process I use. Any organization I'm working with, if you like, if you don't adopt it, I use this process. So what this process does for me is that it makes me look tidy. One, the major thing is that it shows that I understand what I am doing as a tester. I understand the process I am working as a tester. Now, this process process that you see here. It works. Some people call it the traditional way, but believe you me, it works for both the agile environment. Talk about it in a waterfall, a V-model environment. All these are various levels that we go through. And I'm going to take it. I always love to use a building, a house, a foundation. Let's not use the house now. Let's say we have a bare land. There's nothing on it. It's just like a bare land. Nothing is built on it. So the first thing on that land is that before you can start building on it, you've got architects, builders that the architect going there. Once the architect go in there, they'll look at the land. What exactly can we build on this land? They will look, what can we build on this land? Okay, we can still do a 10 duplex on this land. Is it possible? Yes. How do we know? Then they start planning it. How do they start planning it? They'll start looking. Okay, this is what the expectation is. This is what we're putting everything down. All the points that they are going to use to get it done. So, test planning and control. After this, before I move to the second one, I've used the house. I've used the bare land. Now, let me take it back to we that you are testers. Test planning and control. We've started a project. You're on your project team now. You have been given a mandate. You can't you have to first plan it. As a group, what is our expectation? What are our planning phase? What are the things we want to do? What does it entail? In a planning session, you need to start drafting your test plan, your test strategy. All this goes under the test planning and control. Please, in this intern, I'm going to speak to Pat and coordinating any of the mentors, coordinating you. If you're going to do any process for this intern from now on, you must use this fundamental test process. Don't write your story. You must give us every level, break your tags. So when you break your tags, tell me what is under test planning and control. Put all your tags there. So it tell me you've done test plan, test strategy. You are putting it under control. Do you need any training while doing that process? Put it under your control. Now let's go back to the building that you have done. The architects have gone to the ground. They've looked at it. We are going to build 10 duplex there. Now, the next thing they need to start doing, they need to analyze and start designing. How do you analyze? How do we want the building to do? So they start doing all those analyses. Okay, put this. We want the duplex, it should be a 6-bedroom. Some should be 5, some should be 3, 2, varieties. That's the plan. They start analyzing it. Now bring it back to our own testing world. We have written our test plan. We've gotten our user stories. We've written our test strategy. It's been approved by the team. Now we come into our analysis and design. So let's start looking at our test scenarios. What are the user stories? What have they given you? You start drafting all your scenarios out. You start analyzing it. What do I need here? Business analyst, excuse me, product owner, I don't understand this. Can you give me a better clarification? What do you need? This is it. On this website, how do you want it to navigate? What are the screens that you're expecting to see? Do you need a video? Do you need this? I'm just saying it. All those questions, you need to start analyzing them, start thinking. Then, after you have done it, then it takes you to the next phase, which is test implementation analysis. What are the test implementation analysis? The developer, the architect, planners, they've finished analyzing, they've finished designing. Now, they need to start implementing and executing it. So the bricks, they start building up the bricks. They've done all the foundation, put all the irons, then they start building up the iron to the bricks. So it starts forming a big house. They've covered it, put the roof, they've started designing, start putting it. So they are executing it now, designing the house. This is going to be 6-bedroom part, 5-bedroom, 2 toilets, all those beautiful, lovely scenarios. So now that comes back to you as a tester. All the scripts that you have been writing, all the test cases that you've been writing. So that takes me to another word. In testing, it's not that. When you hear me use the word design your test script. In layman, I mean write. WRITE. Write your test script. So it means click on this, you are typing it. That's what it is. But because we don't want it to, when you're professional, you want to be professional with your job. So use the word design. Let it look big. You see some people will just little things that they do. They make you use some big words, and you will be wondering that is it just to send an email that is this? Yes, you have to just put it there so that we all know. Yes, Yami is designing a script. Yami is those are the things that you want to. That's the way we use the word design. I want to design my test plan. I'm designing my test strategy. I'm designing my test script. I'm designing my test cases. So all those things. So now the implementation is the phase and execution. So now we've started implementing and we've written your expected results. Now you need the actual. So they finished building the house. We finished building the finished development with testing. So your project, the project you're working on now, the team that you are in, the developers have finished developing. Now they have sent it to you. So in your level 2, test analysis and design, you have already written your test cases there. So your test cases, we will teach you how to write it, don't worry. Then you've implemented, so you want to do the implementation and execution. So now you want to start executing it. They said the login must have username and password. So you enter the username, you enter the password. Your expectation is that it should take you to Blue Sky page. So now you're on www.bluesky.com. You have entered your username, a valid username, and a valid password. When you click the word, when you click login, the login button, the next thing is just error. You cannot log in, and you take a screenshot. So all those things you have started executing because now you have the system. Now it takes you to the next level. Before I go to this next level, in when you're testing or giving analysis, or you are told to send a report. Let's take an example. If you've just written 2 test cases, 2, 1, 2, you can't say to your manager that, and you are told to execute it. And when you've executed, maybe one passed, the other one failed. You can't tell your manager that one test case passed, one failed. That's not the right way. We work with percentage. So the 2 of them is 100%. So you tell him 50% passed, 50. Once you say 50 pass, he or she knows that the pass rate is what we look at, and we ask question. Are the priorities gone? What is it? Then I'll sit down with you to look at it. What have you tested? What have you analyzed and the likes? Having said that, if you have 5 test cases and 4 passed and 1 is left, someone should quickly type, what will it be? 4 passed, you have fantastic, Samuel, fantastic, 80%. So if I have 4 test cases, I've written 4 test cases, 3 passed, 1 failed, or the other one failed or blocked anyone. What is the answer? 75%. Fantastic. So this is the expectation. You should not say it in numbers. I'm only using 5. Most of the time, your test case can be 100. It can be 400. It can be 50. It can be 80. So it depends. It could be 300. So any amount, but you work with percentage. Use a calculator if you cannot get it. So having done the execution phase, now evaluating exit criteria and reporting. That takes me to another thing. Write these 2 words. Entry, entry spelled ENTRY. Entry criteria and exit criteria. Entry criteria and exit criteria. So what is entry? Entry, I enter. Entry, I enter. Enter. Enter is entry. So in testing, what does this relate to? Entry means we want to start. Starting. We want to start testing. That is an entry criteria. Exit. Can you exit the building, please? Go out. In testing, what it means is stop testing. So remember, entry, exit. There are 2 words, they work together. So entry is to start, exit is to stop. 2. So most of this thing, you have those 2 words when it comes to it. This is, I'm telling you, this is interview question. What is the difference between entry and exit criteria? So evaluating exit criteria and reporting. So now we have done the implementation. We have done the execution. We have done the test planning and control, the test analysis and design, the implementation and execution. So we finished. So we want to evaluate the exit criteria. We want to say we want to stop testing. And we have it. Samuel said he has finished 80% of the test. So we've given, there's a bandwidth, there's a yardstick, there's a measure point that you look as a manager. We need to look, what are the criteria, what are the test cases like, all this. So analyze from there. Have the priorities been tested, the critical ones have been tested? So all those factors are put in place. We have a checklist in a nutshell that you use to do that. And once that is done, you report. The reporting ways in terms of collation, you've executed 80%, 10 is blocked, 10 is failed. The blocked ones, what are the mitigation points? All those answers would have been put there. Then the final part of it will be a test closure activity. At this phase, we actually draft a test closure report. So TCR, it's going to call it TSR, test summary report. So test closure report is like you analyze to say, these are the tests that we have executed, This is the yardstick. If you have a tool that you can bring out a graph to show us that this is 1 minute, please. So this is test closure report. So that's where you analyze to say we finished testing 80% of it a day. This is this is where we have it blocked, and this is the mitigation plan. All those are what you have in for is what you bring into 5. But at the end of it, you now need a face to say, do you want to sign it? Do you want to say that, yes, I, as Yemi, am confident I can give you this application and I stamp my name on it? If you're not confident with it, if the critical bugs have not been fixed, I will tell you not to take a bold step to, to sign off. Leave it to the project managers and the big guys in the stakeholders to take ownership of that. If you have told them that the critical ones are not, some of them will tell you, let's just go for it. So, but that time, it's not your call again. It's their call. So if anything happens, they will not bring it. But I always tell people, when you have in your test closure report, all your open bugs, it must be in the test closure report. That's your TCR to say these are the things, these are the bugs that you have raised. They are still open. This is critical. The state of each of them, and if there are any mitigation plan, put a row there and put it. A simple five page 5 slides, PowerPoint slides, a beautiful one will state everything about TCR. Less than 5 pages. If you have a good one, you can 1 page, you are fine. And you send it, everybody have it. So that tells you that that's a closure activity. Are you confident? Yes. Okay, you've spoken to the UAT team that they are going to take this across. Are they willing to take the box? If yes, then we take that all off. So remember, fundamental test process, please and please, is very key. If you ask me, if you ask me as of today, I can confidently tell you that I use this process. It makes people trust you that you know your job. It makes people believe that this is the process because these are the blueprints, these are the rule books laid down for us. Now, some of you might be thinking that you've been talking about this process. How do we measure our tax under it? I'm not going to go back. I'm going to just take this. So I'm going to explain to you how you add your tax. The first one, test planning and control. Under planning and control, how do we as tester plan and control? We do our test planning, we do our test strategy. We might need some help, maybe in terms of training, some SQL queries and that. Put it under your test plan. Create each tax for it. Design test plan, design test script, training for this particular application, training for Azure DevOps. Put it under the test planning and control. That's your tax. Go back to the analysis and design. What scripts are you designing? Test script for login table, test script for set functionality. Put those tags here. Make it as simple as possible so that people will know what clarity, transparency. It's easier for the Scrum Master to be able to pick your task and add it to the board without even consulting you. What are the implementation and execution phase? Now go back and take it. The execution of login scenario, each of those scenarios you have written in your test analysis and design should be part of the ones that will come here, but it should be executing it. And your day 4, should be each of your each of the cycle that you are doing, anytime you are your execution phase, you must provide a report, a daily report. We have, if it's 20 test cases or 100 test cases you have designed, today, out of the 100, maybe you executed 30% of it. You write it in the report. Show us. There are graphs that can show us this. And at the end of it, so all this under number 4, everything, daily report of your test execution should be under it. Then this place, your 5 should be TCR, test closure report, to say. So that's the way you divide your tasks for the whole project. Nobody will need to come to you. All this project, all this I have said is enough for your 12 weeks in the internship. If you pick it up. So each of the team, please and please, I'm going to make sure that you follow this. If you don't follow the fundamental test process, just have it at the back of your mind. It will help you. You will remember it anywhere. And finally, the psychology of testing, and it's just a wrap up of the day to say a variety of different people may be involved in the total testing effort, and they may be drawn from a broad set of background. They might be developers. That's why I told you, anybody can test. Anybody. Before a developer will bring his code, he has tested it. He has done his unit testing. He has also tried it. He brings it to you. Then you are testing second and you're still finding a bug. Do you understand now? So if the developer has tested, and you've tested and found a bug, so you can see where I'm saying that exhaustive testing is impossible because one person has done it, you are doing it second time, the third person can do it, and that. So it could be professional testers, it could be specialists, it could be performance tester, it could be anybody from the team to just help. Anyone can be drafted to testing. As I said, testing, anybody can test. That ends my class tonight. I say a very big thank you to every one of you. I welcome you on board to our internship, and we are also looking forward to working with you all. So I've got my colleagues on ground. They will be answering questions. We're in the lovely Q&A session. And before the Q&A, I'll ask my question. What are the general testing principles? How many are they? I think there are 12. How many are there for the general testing principles? General testing principle. I have not seen any answer. See, Deborah Harris. Okay, fantastic. So you said it's 7, but I thought it's 12. Is it 12 or 5? 7. Fantastic. Well done, Victor, Damilola, Ugochi, Gideon, Rebecca. Well done, every one of you, Samuel. The first one. I now see the first principle. First principle. If you get it, you get a lolly straight on. First principle.
Testing shows the live presence of bugs.
Fantastic. Well done, Damilola. Well done. The second one, don't see anything again, Damilola. Fantastic. Next person, you can let us know. Next one.
Impossible.
Well done, Deborah. Well done. You can talk again. Fantastic. Number 3, correct. Ugochi, well done. Number 3, well done. Early testing. Well done. Well done. All of you, as I mentioned your name, just don't worry, I have your address. I'll send it. Fairly testing. No, early testing. You wanted, Rebecca, you wanted to write early testing. Fantastic. So number four. Let me see. Who got number 4? Defect clustering. Fantastic. Ari, Rebecca, that goes to you. 5 lollies. Well done. Number 5. The pesticide paradox. Samuel, well done. Number 6. Testing is context dependent. Number 7, last one. Fantastic. Who is this? Abimbola Aris. Well done. I've got this good absence of error fallacy. Well done, everybody. Well done. So what are the fundamental test process? How many are they? 10 or 12? 10 or 12?
There are 5 of them.
There are 5.
Okay, 5.
Huh.
Thank you. Well done. 5, yeah. Well done. That goes to you all. So the first one, it must be in levels.
Test planning and control.
Larry,
Test planning
fantastic.
and control.
Well done. Fantastic. Well done, Larry. 2 lollies. Next person.
Test
You can't talk
analysis
again,
and
Larry.
design.
Test analysis and design. Deborah. Yes, you can't talk again.
Number 3,
Huh?
test implementation
Next.
and execution.
Implementation.
No. Now, Rebecca, Victor.
Test
Victor,
implementation
understand?
and execution.
Fantastic. So you can't talk again. I want to see new names. So we have to, I want to see new names.
Test evaluation.
No. Who is talking? Damilola, you've spoken before. Solomon, go for
Can I
it.
speak?
Test closures on
Yes, please.
Solomon on the line.
Solomon,
Test closure activity.
yes.
Evaluating exit criteria.
Fantastic. That's number 4. Evaluating exit criteria.
That is what you talk about it.
And report. Huh?
Then
Is what you
number
talk about
5.
the
Number 5.
exit and the.
No, Victor, you can't talk. You can't talk. I need someone else. New name.
Number
Solomon,
5.
you've said something. Number 5. Nobody should say it. Who is talking?
Solomon.
Oh, okay. No, okay. Essay. Ogunyemi.
Yes,
Essay. Okay. What's fantastic? Emmanuel, fantastic. Emmanuel, are you saying something?
Yes, test closure activities.
Fantastic. Well done. Well done to you all. So now there are 2 twins, two things that I mentioned. There are 2 twins. What's the first one I said? 2 words.
Error
If you
and
know,
defect.
Expected and actual.
fantastic. Expected and actual. There's this last one. I just said it now. Don't say anything again, Ugochi. Everybody, I know your name. Before you say it, raise your hand. I want to see your names. I'm going to call names. I'm going to call names. Is there, I don't know. Larry, I think there's a Larry Shoboton. There's a Thompson, Mercy. I don't. Please, no, not. I know her. No. So, yes. Finally, I leave the class now to say, if you have any question, please raise up your hand. I'm going to end the class, but I think Rita is going to pick it up from here. So if you have any question for today's class, anything, If not even part of the class, if you have any question, you are free to unmute yourself and ask. I want to say a very big thank you to every one of you for attending the class tonight. And welcome on board. We are all here to help you. And hopefully, one of these days, we all work together as team members. Thank you, everyone. Any question? Any question? Any question? If you have a question, raise up your hand. If you have a question, raise up your hands. Oh, thank you. Thank you, Victor. Thank you. Any question, please? Any question? Try to.
Victor and Solomon, their hands are up.
Oh, sorry. Victor, go for it, please. Let me see. I didn't see. Okay, good. Victor, go for your question.
Okay, all right. Good evening, ma.
Good
First
evening.
of all, I appreciate you. Thanks for taking your time to impact this knowledge to us. Actually, I came late because I got home very late from work today. So during the question section, when asking us a question, you said two things can be tested: software and hardware. I saw that on the chat. So I'm now confused, a little bit confused that we as a software tester, do we also test hardware? That is question number one. Then number two, you said about the manual textbook. I don't want to ask a question about that. That how do we get access to the manual textbook? Because I personally I would love to have one. So that is just my question, man. Thank you.
Okay. All right. So the first question, Rita, are you fine to go for it? Or do you want me to?
Yeah, you can go for it now.
Okay. So the first one is about the hardware and software. So the hardware and software, that's why I said, because you came into the class, but it's good, you just go and watch the other ones, but I'll just iterate again. So I said, what can be tested? Anything you are doing in life, it needs testing. You need to test it. If you go to the market to buy your clothes, when you bring it back home, you wait to just check that it's working, it fits you, it's not too big, it's not too tight. You are testing it. Hardware, software. Hardware, you are a software tester. You are a manual tester. You are an automation tester. You are a web tester. You are an hardware tester. Anything that's got to do with testing, you are. Because that is a discipline. It is a role. It's a name title. It's a job title. But everything we do is still the same thing. So if your question is that how you as a software tester, you are testing hardware, you still need to test it. Anything that requires any application, a package, a product, an item that is given to you as a tester, remove the software, remove the manual, remove the automation. As a tester, I just don't like word tester. I prefer it to be a test analyst. I love that professional way. But as a tester, you are testing. Remove every other thing. Every other thing is just, you go there, an agile tester, a web tester, a pen tester. Everything we are doing is still the same process and procedure. Then the second question you asked about the textbook, the admin will be able to, they will have the textbook. I'm sure severally I did give out that textbook. So it will be posted to you maybe on the WhatsApp or Telegram. So that textbook will be, I'll put that in mind. As you are talking now, I will send it to the admin, and Rita also will help us. She's a mentor, so she will do it.
I've done it already. It's on their QA guide.
Fantastic. Thank you so much. It's there. So you can pick it up from there. Thank you. Thank you. Prompt one. I've got wonderful colleagues. Honestly, you're going to enjoy them all. They are up to the task. So the Victor, who else raised up their hand?
I think it was Solomon.
Solomon.
Sorry, it was during the question and answer. So I forgot to put the hand down. Okay.
Yes. All right. That's great. Thank you. Good night. Rita, any word for us before we leave the class?
Nothing much. Thank you so much. It was a very refreshing class for me as well. And guys, just go back and watch the videos and do a bit of self-development. There are other videos as well by the same tutor, Yemi Ayola. You'll find them on Blue Sky Saturday YouTube channel. So yeah, just get yourself ready for the next class. Thank you so much. Thank you, everyone.
Thank you. Good night.
Good night.
Good night.
Thank you. Good night. Good night, everyone.